All right, good morning, guys. Happy Friday and end of the week. Again, sorry that I'm not here. Hopefully, you guys are having a great day so far. Grad night was amazing. I'll tell you all about it on Monday. Okay, so today what we're actually going to talk about is function operations and composite functions. So it should be fairly easy. There's no graphing today. Hopefully you turned in your papers. Your sub should be Mr. Emerson. Should have collected that. If not, pause this video and make sure that you let him know that he didn't collect his stuff. Okay. All right, so go ahead and take out your notebooks and we're going to get started. As you can tell, I'm not in my house, I'm actually in my classroom, right? Fight On is right behind me. So pause the video, grab your notebooks, and let's get started. right, so you have unpaused this video, and so we are doing example number 4. So we took 3x squared minus 2x minus 1. We're first going to multiply it by x minus 4. So if you multiply it, you see this work right here. The trinomial be multiplied by that lovely binomial right there. You see my polynomial. I collected my like terms, I get this lovely cubic, which gives me my domain, again, is going to be negative infinity all the way to infinity. With our problem over here, again, notice I switched up my g of x and my f of x. So I put the x minus 4 on the top, 3x squared minus 2x minus 1 on the bottom. You see my factoring right over there. I factored it to 2 binomials. There's nothing to cancel out, right? Which is fine. Just can't simplify it anymore. So I want to point out how my domain is written. So notice that if I set x minus 1 equal to 0, I get x is equal to 1. If I set 3x plus 1 equal to 0, I get x is equal to a negative 1/3, right? So which number, if I'm starting at negative infinity, which one would come first? Negative 1/3. So that's your like vertical asymptote, it would be a vertical asymptote in this scenario. So negative infinity all the way to my first POD, union it, start with the same number, go to my next POD, which is 1, union it, and then start at that same number, and then now there's no more PODs, and we go to infinity, right? So that is your function operations, adding, subtracting, multiplying, or dividing. All right, so the next thing we're going to talk about is called composite functions. Okay, so composite functions, so think of it, it's comprised of multiple functions, right? And so we have seen this before a little bit. So I have a little bit of a PowerPoint, right? So composite functions is where we evaluate the inner function, and then we use that answer as the input of the outer functions. So we see it as written as GOF. So it is not a multiplication sign. We see it as like a circle, GOF. I can have it GO of G, right? It could be FOF, right? It could be a lot of things. But whatever value, whatever function, right, is next to your f, that's the first inner function. So I'm going to plug all of this into my next function. So like I want you to think of composite functions as that movie Inception, right, with Leonardo DiCaprio and Joseph Lovett. I don't know what his name is, but you know the guy. He's in a lot of things. So think of it as the composite, right? Inception. Inception is a dream within a dream within a dream, right? Except that composite function is a function within a function within a function within a function, right? So it's just dumb and stupid, but hopefully you guys can remember that that's what the composite function is all about. All right. So we're going to do our first example. So we're going to say f of x is equal to x minus 2. We're going to say g of x is equal to x squared. And we are going to find GOF of negative 5. So basically what this means, I'm going to plug in negative 5 first into my first function. So I'm going to say f of negative 5. So I'm going to say negative 5 minus 2. So negative 5 minus 2 gives me negative 7. This is my new input into this equation. So I'm going to say g of negative 7. So g of negative 7, so negative 7 squared, gives me 49. So this whole answer, GOF of negative 5, gives you 49. Right? If you do it the other way, right, if we say FOG of negative 5, we're not going to get the same answer, right? Because we're going to plug in the negative 5 into the G function first. So I would be like, all right, G of negative 5, that gives you negative 5 squared, which gives you 25. Plug that 25 into that. So we're going to say, F of 25 is equal to 25 minus 2, which gives you 23. Are these the same answers? No, so don't do that. Make sure you pay attention to which problem is written first. Okay, so I want you guys to use these same functions, and I want you to tell me what f of let's go 7. I'm just making this up. Right, so pause it and figure it out. Okay, so here is your answer and your work. So I plugged in 7 function first, or 7 into the f function. So 7 minus 2 gives you 5. Then I'm going to plug 5 in. So f of 5 is equal to 5 minus 2, which gives you 3. So our answer is 3. Right? So, so we can do function within a function with numbers, but we can also do them with variables, right? So our next problem is going to look something like this. F of x is equal to 3x minus 2. Sorry, I can't see. And then g of x is equal to x squared minus 1. We are going to find g of f of x, right? So what does this mean? This means everywhere I see, instead of plugging in a number, I'm going to plug in a variable. Well, guess what? What variable is already there? An x. So I plug in an x, it's already there, right? So all of this is 3x minus 2. So I'm going to take this whole thing and I'm going to plug it in for this x. Oops. Let's draw it right here. I'm going to plug it into that guy right there. So I'm going to say g of, and then it'll be 3x minus 2. So now everywhere I see an x, I'm going to plug in 3x minus 2 squared minus 1. And then I could continue. I can be like, all right, so 3x minus 2, 3x minus 2 minus 1. So 9x squared, and then minus 6x plus 4 minus 1. So I get 9x squared minus 12x, and then 4 minus 1 gives you plus 3. Right? So you get a new problem. Now, let's test it out. All right? We can always test. So pick a number, any number, right? 1. I like that number. Good number. All right, so 1. So let's plug in 1. So f of 1 gives you 3 times 1 minus 2. So 3 times 1 is 3. 3 minus 2 gives you 1. Right? So let's plug 1 in. This just happened to work. So g of 1 is equal to 1 squared minus 1. So 1 squared is 1. 1 minus 1 gives you 0. So hypothetically, if I plug a 1 into this equation, I should also get a 0. Right? So 9 times 1 squared minus 12 times 1 plus 3. So 1 squared is 9. So 9 minus 12 plus 3. 9 minus 12 is negative 3. And what does negative 3 plus 3 give you? It gives you 0. Right? So you can always try things. Right? So I want you to try the same type of problem.
Can I please bring Myra
So
to the front desk, please?
we're still going to use this, and I want you to pause the video, and I want you to try plugging in x plus 1. All right, good luck. All right, guys, we're back. So I just want to point this out. So we're going to plug in x plus 1 in for x. So we're going to plug that in, right? FOIL it out, subtract it, x squared plus 2x. Plug that back into your f of x. Distribute, boom, we get this answer. Test it out, right? Let's say x is equal to 2. Boom, x is equal to 2. If we plug 2 into this, we get 2 plus 1, so we get 3. 3 squared, 9. 9 minus 1 gives you 8. 8 times 3 gives you 24. 24 minus 2 gives you 22. Plug in a 2 here, right? We see all this work. We also get 22. So our test works out, right? So hopefully this is helpful. Also put a con video also up. There should be a worksheet that Mr. Emerson is going to pass out now. And I wish you guys the best of luck. I'll see you all on Monday. Bye-bye.